Transformers are like magic. I think transformers are the second most important invention behind the transistor. It's what makes our electrical grid work and are crucial in HVAC systems. An alternating current transformer is a device that changes or transforms the voltage of AC electrical circuits. Transformers can increase voltage, step up, or decrease voltage, step down, or the same voltage as in a one-to-one isolation transformer. There are some common misconceptions about transformers, especially when someone starts new in the trade. They think if you put voltage inside the primary winding, it goes through a whole bunch of turns of wire, and by the time it gets at the end, it's a lower voltage. Not true. Transformers work off induction. When you have a wire that is flowing electrical current with a changing magnetic field, like with alternating current, and you place a second conductor or wire next to it, it will induce voltage onto that second wire just by being next to it. However, when you just have the two wires by themselves, it's not very efficient at transferring the magnetic flux into that second wire through the air. So we can help it out with a shared iron core. There's a few different styles of cores. The type we're most familiar with in AC is the E core, or some people call it the IE core because it looks like it's made of an I and an E. A long time ago, they figured out that a solid iron core isn't as efficient as multiple laminated sheets of iron next to each other. A step-up transformer increases the voltage from the primary to the secondary coil by having fewer turns of wire on the primary coil and more turns on the secondary coil. This is commonly used to transmit electricity over long distances or in primary controls for direct spark ignition. Conversely, a step-down transformer decreases the voltage from the primary to the secondary coil by having more turns of wire on the primary and fewer turns on the secondary. This is typically used in HVAC systems where lower voltage is required for safe and efficient operations. An isolation transformer, on the other hand, has an equal number of turns on both the primary and the secondary coil, providing electrical isolation between the circuit without changing the voltage level. This is used to reduce electrical noise in sensitive equipment and preventing back EMF from returning onto the grid.
Fun fact.
Have you ever seen one of these little nuggets on a monitor cable or a power supply cable and wondered, what is this? This is a ferrite core. It's basically a transformer. When the current is passing through the cable, when it hits that ferrite core, any magnetic field is induced into the ferrite core and doesn't pass through to that sensitive device. Pretty cool, huh? So in a nutshell, the primary coil creates the magnetic field, the iron core directs it, and the secondary coil transforms it. That's the magic, or science, behind transformers. I'm Professor Butler. I'm a 20-year HVAC service technician and instructor. If you got anything out of this video and you'd like to give me a follow, I'd really appreciate it. Or leave me a comment if you have a video idea that you want me to make. Thanks for watching.